Today, a new session to learn day 23 linear regression training model. In the last session, we have looked at a project with loan approval. Now, we are going to be looking at training models and different techniques that we are going to be using. First is the linear regression, which is a very basic one. Consider we have x and y coordinates such as these. We try to have a simple line or a best fit line, something like this, even though there are points outside this line, right? So, a normal equation that we can come up here for such a linear regression problem is how it works under the hood is something like we have a formula something like this, where matrix x would be all the points that are being mapped for these values, and we multiply it with x transpose and matrix x to the power minus 1, and again we multiply it with x transpose with the y parameter. So x is the feature matrix and y is the target vector or the output that we are looking to seek. And the expression here is this gives us is the gram matrix, and this one is the best fit coefficients. So you can think about this as this coefficient line which is running around this one, and this one is the gram matrix or the possible output, right? Ideally this would be 1, but yeah, this coefficient would have some deviation around it. Next thing is we also predict for a value, let's say a value 9, which is around 79 or 80, that's what it shows. So yeah, consider some prediction around this one. And there's also mean squared error calculation with some points being deviated, so we get around 2.7 or something like this, right? Next is batch gradient descent, is another technique where uh, consider in batch gradient descent we are going to be dealing with batches of data instead of all at once trying to fit specific data, and that's when we are going to be also having ETA and number of iterations to have multiple iterations to go through. So this is a formula to look at batch gradient computation. So cost versus iteration. So um, cost in batch gradient is kind of a tricky word here. Cost here really means the kind of error whether the next point, like we see here, is either going down or up, and then having to adjust this line instead of it having to be a straight line like this linear regression model. The batch gradient descent adjusts itself. So one of the things that this formula does here is this is the ETA and gradients factor, which is computed as this here, right? So this is a formula. You can look at some online resources on how this formula works, and I would not be a mathematical person, or I at least would not be a mathematical person. If anybody has some easy way to understand uh, how batch gradient descent formula is, uh, please do post it in the comment section. Happy to hear um, scholars in mathematics too, right? So ETA is nothing but the learning rate or the number of ups and downs that this is going to take up, and the this one is the original value, and this would give the new updated position that it should pick up. So this would be this way, this way, this way. So instead of a normal line. So that's the whole idea. And batch gradient descent, as iterations increase, so the learning rate decreases. So that's one thing that we can see. Here, if you see error starts spiking up as we mean squared error starts spiking up as we increase the iteration. That's one other thing. So in a normal equation, its computation is n power 3, small number of features. More number of features, it would be more. Batch gradient descent is m into n per iteration and large data sets. So SGD is stochastic gradient descent, which we are going to be looking at in the next session as well. More of a mathematical topics, which you can think about it would be a graphical kind of visualization that we are going to go through. But yeah, these were a few things. And next is we have residual plot. Let's see. Uh, this shows what is the point data points that are not predicted good or the ones that are outside the prediction line. Right. So these were certain topics for today. Hope you found this video helpful. Please do share any comments or any thoughts around these mathematical formulas and how to go about this if you have a way to do that. Thank you.